In this class, we'll start with the operations on stack. We can follow the following operations on the stack. That is, first operation is stack, then next push of item, next pop, next peek, next is empty, and last size. These are the operations we can perform on stack, right? The operations are stack, push, pop, peek, is empty, and size. So these are the operations which we can perform on stack. Now we'll check out the meanings of that. That is, first one, stack. The stack function creates a new stack that is empty. It needs no parameters and returns an empty stack. It means the stack operation is going to create a new stack. When a new stack is created, by default it is empty only. And this operation does not require any parameters, and it returns an empty stack. This is a stack. The next one is push. Push means equivalent term is insert or add, right? So to insert or add, we need an item. That's why the operation is push of item. Push of item. This operation adds a new item to the stack of the top of the stack. Push of item. This operation adds a new item to the top of the stack. It needs the item and returns nothing. So in the previous class also we discussed that the push operation is nothing but adding a new item into the stack. Where we are adding? At the top of the stack, because we know that stack contains only one end called as top. From that end we are pushing and popping. Now push means this is the item to be pushed into the stack from the top end. It means this, the recently pushed item is near to the top of the stack, and this needs some item or one item to be pushed at a time, and this is not going to return anything. Then the next operation is pop. Pop means it removes the top item from the stack. It's a reverse operation. If you compare push versus pop, both are opposite. Push adds, whereas the pop removes the topmost item from the stack. It needs no parameters and returns the item. Once we perform the pop operation, the stack is modified. It means the number of items into the stack will be one less after performing pop operation. When you perform the push operation, after completion of push operation, one item to be added to the previous items. Then peek. This returns the top item from the stack but does not remove it. Peek means it only returns the topmost item from the stack, but it will not remove that. It needs no parameters. The stack is not modified. Only it gives information about the topmost item of the stack. That is peek. Then the next operation is empty. The function itself says that is empty means we are checking here. That is, it tests whether the stack is empty. It checks whether the stack is empty. It needs no parameters and returns a Boolean value. That is, at the end, you will get either true or false, or 0 or 1 value will get. Stack may be empty or may not be empty. Depends on the current status of the stack. You'll get the Boolean value from this function, that is empty. It checks the stack is empty. The results are Boolean values. Then the last operation is size. The size returns the number of items on the stack. It means it gives the size of the stack. It needs no parameters and returns an integer. The size operation, after completion of that, is going to return one integer value. It means that integer value is nothing but the actual size of that stack. Right? These are the operations we can perform on stacks. Now, we'll go in detail that two operations, that is one push and pop operation, will check with algorithm and example. Right? Now, if you see here, first one, that is algorithm for push operation, right? Algorithm for push operation. It means we want to add the item into the stack. For that, the parameters required are one, the operation is push, then the parameters what we need is stack is needed, then top we need, size and item to be inserted or pushed. These are the parameters we need for performing push operation. Now see here, the step 1, if top equal to n minus 1, if the top has reached its maximum, then straight away you can say that stack is full and exit. It means further push operation cannot be performed on that stack because it is full. The top has reached its maximum, that is n minus 1. Suppose if top equal to n minus 1, condition is false, then only it goes for step number 2. It means the current top will be incremented by 1. Whatever the top value, that will be incremented by 1. It means before adding or pushing an item into the stack, first you have to increment the top by 1, right? Then you'll get an empty space. There you can insert an item into it. That we are doing it here. In step number 2, we are incrementing the top value by 1. Previously, whatever the value it may be, that will be incremented by 1. Once it is incremented, then at that particular place, that is step number 3, stack of top, now current top is equal to item. It means that particular item will be inserted into the stack of top. It means we have performed the push operation here. Right? This you can, we'll see with the help of one example also. Right? Okay, see here. In this example, if you observe, this is an empty stack. Nothing is there. If the stack is empty, then top equal to -1. As usual, we are familiar now. In this lesson, it is less than 0 because our array starts with 0, position starts with 0. That's why one step less than that. It means the top equal to -1 means the stack is empty. Nothing is there in this. Now, we want to insert an item 1 into the stack. Right? At that time, first step, you have to increment the top by 1. That is equal to top plus 1 is there. The present value of top is -1, right? So -1 plus 1, that is equal to 0. Top becomes 0. That we are writing it here. Top becomes 0. Then The third step, stack of top equal to item is there. That we are writing it here. Stack of 0 is equal to 1. It means the value 1 is inserted at stack's 0th position. It means this will be the first item where we are inserting into the stack. I hope you understood this. The one item is inserted into it. Now, if you want to insert one more item, that is 2, into the same stack, then again you have to increment, check the condition whether if top equal to n minus 1, top equal to n minus 1 means further insertion is not possible. Think that the first condition is false, then we are going to step number 2. Then you have to increment the top by 1. So present value of top is 0. Top equal to top plus 1 means top equal to 0 plus 1. That is nothing but 1. We have reached the top, that is empty. In that position, we want to insert or push item 2. That is stack of 1 equal to 2. It means the item 2 is inserted or pushed into stack of 1. That we have shown it here. This is 0th position. 1 is there. The first position, 2 is there now. Further, if you want to push one more item, 3, into the stack, then again repeat the same procedure. Increment the top by 1. Increment the top by 1 means present value of top is 1. So 1 plus 1 is 2. Top becomes 2. That we are writing it here. Top equal to 2. Then step number 3. Stack of 2 equal to 3. It means the item 3 is inserted at stack of 2. That we are showing it in this diagram. Now, in this stack, the item 3 will be the topmost item in the stack. This end is nothing but top end. Now, top has reached 2. Total size of this stack is 1, 2, 3. Right? 3 items are there. Now, this is nothing but the push operation example. Now, we move on to the next one, that is, this is completed. 3 steps we have completed. Once the push operation is completed, then it returns. It means, again, it goes back and checks the condition. Further, if you want, you can go on adding, pushing the items into it. I hope you are familiar with now this algorithm, 4-step algorithm. Now, we move on to the next one. Reverse operation, that is pop operation. We'll check out. See here. Next algorithm, we'll check out the algorithm for pop operation. To perform the stack pop operation, we need operation name, that is pop. Then the parameters we need is stack, then top and item. These are the 3 parameters are required to perform the pop operation. Then we'll see. In case of push operation, we have checked the first condition whether it is full or not. Like that, in the pop operation also, you have to check one condition first. If top equal to null, if top contains nothing, means it is empty. If the stack is empty, means we cannot perform the removal operation, that is pop operation. Then straight away, you can terminate the process. Right? That we are checking it here. See here, in the step 1, if top equal to null, then print stack is empty. If nothing is there in the stack, if the stack is empty, means we cannot perform pop operation. So straight away exit. This is one case. The second case, if top equal to null, condition is false, then only it moves to the step number 2. Right? In this step, again, item equal to stack of top. Stack of top is assigned to item. Stack of top is assigned to item. It means the topmost item of the stack will be removed first, right? That's why the stack of top is assigned to item, that item. The step number 3, we are completing the process of removing the topmost item of the stack by using this particular step, that is top equal to top minus 1. Top will be decremented by 1. It means top is decremented means the previously top, assume that it is 2 means 2 minus 1. It means presently it is 1 means the second. It means the previously top was 2, that element will be popped from the stack. The same thing you can check out with example. The same algorithm steps. These 3 steps can be checked with an algorithm. Then 4th step is return. The process goes on. Removal of item at a time. One item can be removed from the stack. If you want, you can continue with the return. Right? Now, before completing this, you will check just an example. Then we'll conclude that. See here. If you are observing here, this is the stack, right? Stack contains initial step, that is the values 5, 10, 12, and 15. Total we have 4 items in this stack. Now we want to pop the items from this stack. As we know that stack performs last in first out operation. Right, last in first order operation. The recently pushed item which is near to the top will be removed first, right? Based on that principle, the item number 15 will be removed first. How to remove? Just by decrementing the top by 1. Present top is, this is 0, 1, 2, 3. Now the top value is 3. Right? If you decrement the value of top by 1, it means top equal to top minus 1, 3 minus 1, 2. Top is here now. The top is changed from position number 3 to 2. It means the position 3 element will be, item will be removed. Just by decrementing the top value by 1, we can remove the topmost element or item of the stack. It means 15 is popped here. Now, if you want to pop 12, again decrement the top by 1. It has 2 minus 1, 1. Top has reached 1. It means the item 12 is popped. Now, if you want to remove the item 10, again decrement the top by 1. 1 minus 1, 0. Top as it is 0. It means position 1 will also be removed. Now, if you want to remove this 5 also, then top equal to top minus 1. Right? At that time, top has reached minus 1. It means the stack is empty now. Further pop operation is not possible because top equal to null. Right? So this is the example concerned to pop operation. Then, after knowing the push and pop algorithm and example, now we'll move on to the next thing called as application of stacks. Application of stacks. The simplest application of stack is to reverse a word. The simple application of stack is reversing a word because stack follows last in first out operation. Last in first out operation, right? If you insert the items, first A is inserted, next item B is inserted, next item C is inserted, it means once you perform the stack pop operation, then what you'll get is First you have to remove C, then you have to remove B, then you have to remove A. It means CBA will be the solution you get. That's why you're saying that stack you follows the principle of last in first out. So the application, simplest application is stack is to reverse a word. Stack reverses the given word. That is the first application. Then next, another application is an undo mechanism in text editors. If it is a text, if you are using text editor, then undo can be done with the help of stack. It means when you are working with, example, MS Word or WordPad or Notepad, I typed. What I typed is computer as, say, computer as I typed. Now I don't want the last typed letters. Then I can go for undo. I'll undo, then automatically the last word is undooed. It means it will be cancelled. Such operation can be done with the help of stacks. That's why we are writing it as the application is an undo mechanism in text editors. Then next, bracketing. This is a process when you need to access the most recent data element in a series of elements. Bracketing is nothing but this process is going to access the most recent data element in a series of elements. Recently entered data elements can be accessed with the help of stack. The technique is bracketing, backtracking. Right? The technique is backtracking. The name itself specifies that we're tracking back. The recently added data element will be collected in a series. That's why the operation is called as backtracking. The next one, language processing. Compilers syntax check for matching braces is implemented by using stack. When you're writing a C++ program, during compilation process, the compiler checks whether all the braces, so if we are putting an opening brace means the matching closing brace should be used, right? It checks that will be implemented with the help of stack back. Then support for recursion. The process is continuous. If you put the process of push or pop in a loop, the process is continuous. That's why it's a recursive process. Then converting a decimal number into binary number. Conversion of decimal to binary number is one more application. Then to solve Tower of Hanoi, the problem is that can be solved with the help of stacks. Then expression evaluation and syntax parsing. The expressions can be evaluated with the help of stack. In future classes, you come to know about this, how it evaluates, right? Then next, conversion of infix expression into prefix and postfix expression. These are the expressions that are coming in the next heading. That is conversion of infix expression into prefix and postfix expression. This can be done, and this can be used in quick sort also, right? Then runtime memory management purpose, the stack can be used. It means these are the applications of stack. So after knowing stack, now we move on to the next heading called as arithmetic expression. Before stating arithmetic expression, first we'll check out what is an expression. An expression is a combination of operators and operands. An expression is a combination of operators and operands. The operands may be either an integers or variables. Either it may be a constants or variables. In the sense, sometimes it may float also. That's why I can say it in a general form. That is, they may be a constants or variables. The combination of operators and the operands, where the operands may be variables or constants, is known as an expression. In that, the first type of expression we will consider, that is arithmetic expression. An expression is a combination of operands and operators that after evaluation results in a single value, is known as arithmetic expression. One more way you can say that the arithmetic expression is nothing but an expression which contains only the arithmetic operators. Then such expression we will call it as arithmetic expression. And the operands consist of constants or variables. These arithmetic expressions are again divided into three types. One is called infix expression, second one is called postfix expression, and third one is called prefix expression. Infix expression, postfix expression, prefix expression. These are the three expressions we are studying now under the heading called as arithmetic expressions. Now, we check out first. What do you mean by infix expression? If an operator is in between two operands, then it is called as infix expression. If an operator is in between two operands, then it is called as infix expression. Then operands may be either constants or variables. For example, if you write a plus b is an example here. Here a is operand, b is also an operand, then plus is an operator. It means a and b are the two operands, plus is the operator. This operator is in between two operands, then it is called as infix expression. Now, the second one, that is postfix expression. If an operator follows the two operands, then it is called as postfix expression. If an operator follows the two operands, then it is called as postfix expression. Again, the operands may be either constants or variables. For example, if you check here, AB plus. In this example, A and B are operands, plus is operator. It means the operator is following the operands, two operands. If an operator follows the two operands, then it is called as postfix expression. Then next one, prefix expression. Third one is prefix expression. If an operator precedes two operands, then it is called as prefix expression. I'll repeat, if an operator precedes two operands, then it is called as prefix expression. For example, plus AB. In this example, plus is an operator, A and B are operands, right? That's why we stated that if an operator precedes, it comes first, operator first, then two operands, then that is an example of prefix expression, right? Then next, you can check out the tables here, right? So in this table, if you observe here, infix expression, in this example, three operands are there. A, B, C are the three operands, then the operators are in between them. A and B are the two operands, in between there is a operator. Like that, B and C are the two operands, in between there is a operator. That's why it is called as example of infix expression. Then the second, two brackets are there. First bracket, you can consider this is one operand and this is second operand. A plus B is one operand, C plus D is another operand. In between these two operands, there is a asterisk. That is again the operator in between the two operands. That's why this is an example of infix expression. Like that, the next example also, that is A slash B. A and B are the operand, slash is the operator. Again, example of infix. Like that, a lengthy expression is written here. A slash B into C minus D plus E slash F slash of G plus H. Lengthy expression. If you observe this also, again, the operators are in between the two operands. That's why this is also an example for infix expression. Then in the next, with the brackets given, this is one operand, this is another operand. Again, the operator is in between that two. Again, this is one operand, this is D minus C is another operand. Again, the operator is minus in between that two. The complete bracket, this is one operand, then this is second operand F plus G. Again, in between there is an operator. So, it is again an infix expression. Right? Like that. If you check out here one more example, that is minus plus ABC. Minus plus ABC. If the operators are, right? If the operators are preceding the operands, then that is called as postfix expression. Sorry. Prefix expression. If the operators are preceding the operand, then it is an example of prefix expression. This also, check out here, the operators first, then the operands. That's why this is also a prefix expression. It means in the today's class we have checked the stack operations, right? We'll go back. You can see here in the today's class we have seen the topics related to stack. That is, we have begun with the heading called as stack operations. In this we have defined stack, push of item, pop, peek, is empty, and size. These are the operations which we can perform on stack. After knowing the meanings of the operations, then in detail we have completed the first operation, that is push operation, right? Push operation algorithm we have studied, right? In this algorithm, right, there are 4 steps we have used. This, to perform push operation, we need 4 parameters, that is, one stack is required, top is required, size and items are required. These 4 parameters are required to perform the push operation. Then the first and foremost condition should be checked is whether the stack is full or not. If the stack is full, means push operation is not possible. That we are checking with the help of step 1, that is if top equal to n minus 1. If this condition is true, if this condition is true, means the stack is full, then exit. It means push operation cannot be performed on that stack. Suppose if the top equal to n minus 1 is false, then only you can perform the next step, that is top equal to top plus 1. The value of top will be incremented by 1, so that you will get one empty space. There we can push an item into it. That we are writing in step number 3. Step number 3 is performing push operation, and step number 2 is changing the top position. It means we are getting the space, the topmost space, empty space there. We are pushing item into it. That we are writing it as stack of top equal to item. It means item is assigned to stack of top. Then return. This process goes on until you finish your push operations, or else the first condition becomes false. Until that, you can go on repeating the steps. With examples also I checked that. Then after knowing this, we have completed one more called as, that is pop operation. In this also we take an example, we have popped many items. For that again, to perform this pop operation, we need three parameters, that is stack, top and item. Stack, top and item are the parameters we need to perform the push operation. To perform this push operation, first condition you have to check it whether the top equal to, whether the stack is empty or not. If the stack is empty, then pop operation cannot be performed, right? For that reason, we are checking the condition, that is step 1. If top equal to null, then straight we can print a message that is stack is empty and exit. It means pop operation cannot be performed on an empty stack. Suppose the step number 1 is false. If top equal to null, it is false means the stack contains some elements, then it is possible to perform the pop operation. Then you can move on to step number 2. If the step 1 is false, then we are moving to step 2. Then stack of top, we are identifying the stack of top, that item, right? Stack of top is assigned to item. Then step number 3 is removing that particular item from the stack just by decrementing the top value by 1, that is top equal to top minus 1. Then return. This process goes on at a time. We are adding one item into the stack, or we are removing one item from the stack. This we have learned. Then after that we have learned the applications, right? Applications of stack we have studied. Then after that we have completed the last part, that is expression, right? In that expression we have completed the meaning of infix, prefix and postfix expressions with examples. If you find any difficulty, just post your doubts so that I can clear your queries, right? In the next class we'll start with the next topic, cues, right?